go right above the star.
So do I just push that red button?
No, it's already going. Okay, so since there's no internet today, isn't that fun? So let's talk about this idea of momentum. And so when you look at momentum itself, and you have to differentiate between a change in momentum and momentum. So momentum itself is just mass times velocity. It's the simplest equation that exists. But hidden within this idea that number one, it's a vector quantity because you could have a positive or a negative velocity. Therefore, momentum could be positive or negative, therefore it's a vector quantity. So you only have momentum if you have velocity. But you always have inertia. Okay, so inertia is just a resistance to a change in motion. So you will as long as you have mass, you're going to have inertia. But you're only going to have momentum if it's moving. So that's the baseline. Now, what we do is we look at how do you change momentum. So changing momentum can equal a whole bunch of different things. The simplest is it could be momentum final minus momentum initial. Okay, cool. You could also have mass times V minus mass times V naught. You could write that as mass times V minus V naught. Okay? There you go. Now, all of that also equals net force times time. And the reason I say that that's net force and just not force is because of the fact that if I push on this wall, I'm exerting a force, but the momentum of the wall isn't changing. Now, I push on that wall, and then I move, and I accelerate, and my momentum changes. That's going to be net force versus time. So just because a force is being exerted on an object doesn't mean that the momentum is going to change, because that doesn't mean that the velocity is going to change. Tom?
Yeah, I am.
Okay.
Is this a bad time?
Well, no, not really. So, here, stop that camera for a second. Well, it's